I don't know how I got stuck following Unsi because that was awesome. I am really, really looking forward to Diego. There we go. Okay, so I've got a disclaimer. My disclaimer doesn't come from our lawyers, it comes from our PR department. Everything I say is my own opinion. It's not necessarily the opinions or views of my employer, the LDS Church. So I love coming to conferences like this and telling people that I work for the LDS Church, because a lot of them give me a really strange reaction. They think that I work for some white chapel sitting on a corner somewhere, and that's not the case at all. The LDS Church is a global church. We've got about 16 million members worldwide, about 84,000 missionaries. We have a huge humanitarian effort, and we also own and operate 3 universities, the biggest of which is Brigham Young University with more than 32,000 students in Provo, Utah. All right, so let's talk about Cloud Foundry. So we have been running Cloud Foundry for about a year. We have it deployed on vSphere, running in our own data center on the campus of Brigham Young University. And we've had it deployed in production for about a year now. And we've been really excited about that. After we deployed it into production, we didn't really let everybody come in and just start using it for a variety of reasons. Probably the biggest of which is we had to learn how to actually operate Cloud Foundry, figure out what happens if it were to go down, and just learn what we needed to do to fit Cloud Foundry into our organization. So we invited a few teams within our organization to deploy their apps onto Cloud Foundry, and we worked very closely with them. And over those 8 months, we really evolved our Cloud Foundry quite a bit to make it really fit well with what we're doing, understand what our developers' needs are, and to build out something that really works well for our organization. And then this past February, we had a big launch event where we invited all the developers within our IT organization to come and learn about Cloud Foundry and to open it up to all of them. And back in February, we thought we were doing really awesome with Cloud Foundry. We had somewhere between 40 and 50 applications deployed on Cloud Foundry, and we thought that was a lot. And we were really excited about that, but just in the past 4 months, as a whole bunch of new developers have onboarded onto Cloud Foundry and started using it, we're now hosting more than 200 applications. And that's really exciting, but it's also really nerve-wracking at the same time. Causes a lot of stress trying to keep that many applications up. Now, to be fair, out of those 200 applications, maybe a dozen of them are actually production applications. But we've got a lot of development work going on, and I expect that number of production applications to increase very quickly. And we like Cloud Foundry so much in our organization that we have actually made it our strategic platform for deploying custom-built applications. Now, a little bit about our team. We're 2.5 developers. I say a half developer because my manager spends about half of his time doing management and HR stuff, and the other half developing. I think he'd rather develop full-time, but somehow he drew the short straw and ended up having to do some management. And then we've got 3 operations personnel that help us out with Cloud Foundry, but they don't do Cloud Foundry full-time. They just help us out with it, and then we've also got an intern. And we have a huge passion for efficiency. In fact, the whole reason for our team existing is to make it easier for developers to deploy their applications. And that's really why we picked Cloud Foundry, is because Cloud Foundry solves all of our problems. It makes it absolutely trivial for a developer to take their application and deploy it. All right, so I want to talk a little bit about some of the value that we get out of Cloud Foundry. And when talking more about as operators of Cloud Foundry, I think our users of Cloud Foundry, I think a lot of you understand that really well, what kind of value you can get out of it. It's easy to deploy an application, the reliability and the scalability. But for me as an operator, the self-service part of Cloud Foundry is huge. If a developer can go out, build their application, deploy it to Cloud Foundry, bind all the services that they need to it, be able to go out and troubleshoot their application without having to engage my team, that's a huge win for the developers because they're being productive, and it's a huge win for me because I don't have people coming to my desk and bugging me and trying to get their application figured out. So it gives me more time to enhance Cloud Foundry, to work on Cloud Foundry, and make it a better experience for our developers. I think one of the other really big values that we get out of Cloud Foundry is that it's customizable. It's customizable on a lot of different levels. For one, the service brokers make it really easy for us to integrate with the systems that already exist within our IT organization. By using the service brokers, we can actually extend kind of that self-service model to other teams within our group, right? So if we've got somebody else managing Oracle databases, for example, we can build a service broker that integrates Cloud Foundry with Oracle, and now the DBA has more time to spend actually being an administrator of the database rather than just setting things up and trying to keep the developers happy by configuring their databases. So we're able to automate a lot of that. I think another level where Cloud Foundry is very customizable is in its architecture. Everything's fairly loosely coupled, so we can actually inject our own components into a running Cloud Foundry without modifying Cloud Foundry. So if we need to know when an application starts up, we can do that without touching the Cloud Foundry code. Or if we need to know when an application crashes, that's really easy to pick that up and to communicate with the whole Cloud Foundry system. But probably the best way that Cloud Foundry is customizable is the fact that it's open source, right? In fact, I don't think it would be possible to deploy something as complicated as a platform as a service if it weren't open source. There's just too many moving parts. Every organization is just a little bit different, so if you don't have that visibility to be able to get in the code and figure out what's going on, I think it'd be a nightmare to try and deploy something as big as Cloud Foundry without having access to the source code. And it also gives us a lot of freedom, too, to be able to go in and tweak things to make it work the way we want it to work, or if we find bugs or want to make enhancements, we can do that. And working with Pivotal has been awesome. We've contributed dozens of pull requests, and it's really been a pleasure to work with the Cloud Foundry community. All right. So let me talk a little bit about some of the custom components that we've been able to build within our organization. A long time ago, Cloud Foundry had this concept of being able to remote debug into a deployed application, or to open a console port into that application. So if you had like a Rails application, you could use the Rails console and go in and kind of play with your application that was running in Cloud Foundry. For us using Java applications, we use JMX for that. But it was really hard to secure that, and so rightfully so, Pivotal pulled that out. I think we got a little bit frustrated with that when we did, but in the end it didn't matter because it's open source. We took that feature, we put it back into our code base, and we deployed it. And then sitting in front of that to secure it, we built a tunnel mechanism that authenticates the user so that they can actually tunnel in to do a remote debug or JMX or whatever. And it really gives our developers a lot of visibility as to what's going on inside of Cloud Foundry, inside of that black box. We've got a lot of value out of that. One of the other things that we've built is a custom HTTP proxy because we want some of our applications on Cloud Foundry to be able to access the public internet, but we don't want all of them to have access. We've also integrated with our enterprise monitoring and alerting. So for example, if an application crashes, we can issue an alert to our alert system, and if the developer actually cares about that application crashing, they can get a text message or an email or whatever it might be. And then we've built a really nice integration between Logregator and Splunk. So instead of just taking Logregator and using syslog to plug it straight into Splunk, we built a component that sits between them that takes those syslog messages and forwards them to Splunk. But when it does that, it associates a lot of the metadata that comes with your application with all of those logging events going into Splunk. So our Splunk users can go into Splunk and say, hey, I want to find out all the logging messages for my particular space or my particular org or just my app by the application's name rather than the application's GUID, or be able to search based off of routes that might be bound to the application, that sort of thing. So I really wish I had more time to demonstrate this. We just barely pushed this out to production a couple weeks ago, and it's a really, really awesome feature. All right, we've also built about a dozen service brokers. This is just a few of them that I'll go over quickly. We integrate with AppDynamics. We have a bunch of internal web services that we enable our developers to bind to with Cloud Foundry as services. We integrate with HP Service Manager for our enterprise configuration management. We have Identity, LDAP, MarkLogic, Oracle, Single Sign-On, and Splunk. We've got a few other service brokers, but these are the most significant ones. And we've built all of our service brokers and all of these custom components using Java and Spring. Now, we've talked to a lot of people about this, like, why in the world are you using Java? You could be using something really cool and sexy like Go, or Cloud Foundry's already written Ruby. Why aren't you using that? And there's a couple of good reasons for that. Just like most enterprise IT shops, we're a Java shop. We have a lot of Java developers. We already have a lot of infrastructure for supporting Java engineers and a lot of tooling around Java. And so that weighed heavily in our decision making. But also Java works with all our existing systems. We know that if we're going to integrate with a system like Oracle or MarkLogic, that we can do that with Java, and we can do that fairly easily. So we already have teams within our organization that support Java as a platform. And I think the third reason is that Spring Boot makes deploying Java applications incredibly trivial. With all of our components, we're using Spring Boot. In the past, traditionally, when you think about deploying a Java application, you think, well, first, I got to go set up my web container, whether it's a JBoss or a WebLogic or Tomcat, and then I've got to build my application and deploy it to that container. Spring Boot gets rid of all of that. I just take my Java application, package it up with Boot, and I can run it. And it makes it incredibly trivial, incredibly simple now to deploy Java applications. Now, one of the big problems that we had in choosing Java is that we didn't have any libraries to communicate with the existing Cloud Foundry system, so we had to build a bunch of them. So about 2.5 years ago, do you guys remember the Cloud Foundry on a stick? Way back in the day, that'll probably date you in the Cloud Foundry community. But I had this Cloud Foundry on a stick, and I really wanted to push Cloud Foundry in our organization, so I started to reverse engineer it. And I knew that if I could understand what NATS was doing, I could understand how Cloud Foundry worked, and one thing led to another. And I built a NATS client in Java. It's been out there for about 2 years. It's really mature now. As I got into playing around with NATS and figuring out how Cloud Foundry works, I realized that there was a lot of duplication and a lot of complexity with how the different components communicate with each other. So we built a really thin NATS Cloud Foundry abstraction that makes it easy for us to interact with NATS and with the different Cloud Foundry components. We also have support. So Cloud Foundry right now, this will change sometime in the future, who knows when. But right now, Cloud Foundry has its own monitoring system. I use it with these REST endpoints that each Cloud Foundry component publishes called HealthZ and VARZ. And then Cloud Foundry components can discover each other using the NATS message bus. We tie into all of that. All of our components, they look like any other Cloud Foundry component running on Java. We also support log aggregator, so we can log on behalf of applications. We support service brokers APIs, of course, and then we built a few utilities to make it nice to work with BOSH, because all of these components that we've built, we deploy with BOSH. And of course, all of these components are open source. They're out on GitHub and the Cloud Foundry community project. These are the project names. If you're interested in building Java components for Cloud Foundry, I'd highly encourage you to go and check it out. All right, I'm a developer. I really don't like slides. I think code communicates things a lot better than slides if you're technical. If you're not a technical person right now, it'd probably be a good chance to check your email or something, because we're going to get really technical really fast. So what I've built here is I'm pretty sure that this is the world's simplest Cloud Foundry service broker. And if anybody knows of one simpler, I'd love to see it. I've seen a ton of Cloud Foundry service brokers, and I think this is the simplest. Now, granted, it doesn't actually do anything, but it's a good demo. It's a good demo. So right here at the top, you'll see I've got these annotations, and these are provided by Spring and Spring Boot. And back in the day, when you were building Spring applications, you'd start out with these reams and reams of XML configuration files. And for some reason, we thought that was cool. But I think we've finally gotten over that. And now, this is all I need to do to configure Spring. And it doesn't just set up Spring and set up some basic defaults for Spring, but it'll actually embed a web container into my application. So now I can build a web application all with these 3 annotations. Now, I also want this service broker to act like any other Cloud Foundry component. I want it to be able to be monitored by collector or whatever you might be using to monitor the components running in your Cloud Foundry deploy. So I add this annotation right here that says, hey, I'm a service broker. And this depends on being able to connect to NATS, so I can configure a NATS connection. And that's all I have to do. And my application will automatically start publishing VARZ and HealthZ information over Cloud Foundry. So Very simple, very straightforward. But I also want to say, hey, my job application here is a service broker. Now you have to understand, when you're building a service broker in Cloud Foundry, it has to do basically 5 things. The first thing it needs to be able to do is tell the cloud controller, hey, these are all the services that I broker, and here's all the plans and configuration for those services. So in order to enable that, all I have to do is put this annotation on this class, give it some credentials that the cloud controller will use to connect to this broker, and it's a perfectly valid service broker. Right now, with just this one Java class, if I were to run this, it's a valid service broker. The cloud controller would connect to it and it'd tell the cloud controller, hey, I do a whole lot of nothing, but it is in and of itself a valid service broker. So let's go and look at what it takes to do a service broker. So like I said, there's 5 things to a service broker, right? There's 1, publishing all your services and plans to the cloud controller. And then there's provisioning and deprovisioning of services. So if I'm using the CF command line client, when I do a CF create service, eventually that's going to result in a provision call to the service broker. Likewise, if I do a delete service, it's going to result in a deprovision. So here in my actual service broker, well, I'm sorry, let me take a step back. So I've got a service broker right here, and I need to tell the cloud controller some information about it, and I do that very declaratively just with these annotations. So I give it a name. This is the name that's going to be presented to the user, and likewise, this is the description that's going to be presented to the user. And then I can list out as many service plans as I want, and that's all I have to do. I don't have to worry about the REST API itself. I can just very declaratively go in and say, hey, here's the service broker. If I want to add tags or metadata or those kinds of things, I can do all that with the annotations. So now when a user says, hey, go create me a service, Cloud Foundry, eventually it's going to result in a provision call to the service broker. And with our library, all I have to do is annotate a method with provision. And this method is eventually what will get called when a service gets created. Now, like I said, this service broker doesn't actually do anything. It logs something out to the console, and that's it. So if you were to build a real service, what we're hoping that this framework would allow you to do is to be able to go in and focus on your business logic for building a service, for actually going out and provisioning something and not worrying about the REST API. And I think we've done a pretty good job of that. I think it's about as simple as we can get it, and that's what we can do here. If I need to provision a service, I just do it. Likewise for deleting a service. And then for binding a service, it's slightly more complicated, because really what happens when you bind a service in Cloud Foundry, you're saying, hey, I need to get credentials to access this provisioned service and give them to my application. So when you bind, you actually have to go and create some credentials to pass off to the application. But this is all the code that you have to do, and likewise for unbind. So fairly simple. All right, the source code for this really simple service broker, it's out on GitHub. Here's the URL for it if you want to go check it out. So in the future, you saw from Unsi's talk just now, Cloud Foundry is evolving very quickly. And one of the things that they're really moving towards is this thing called etcd. At first I wasn't very excited about etcd, but now that I've gotten and played with etcd, etcd is awesome. It's incredibly powerful. And so I wanted to be able to integrate with it, and I went and looked at a whole bunch of Java clients. Now, if there's somebody in this room that's written an etcd Java client, I'm sorry, but all the ones that I saw out there, they all stink. So like I did with Nats, I went and wrote my own client. And I think it's a really powerful client. It's really able to leverage a lot of the powerful functionality that you can do with etcd. It's at beta quality right now. It needs a little bit more testing, but we'll be pushing that out pretty quick. And then as Cloud Foundry evolves, as we saw, Diego's going to change a lot with how Cloud Foundry works. And that's one of the things that we want to stay on top of and really be able to follow and make sure that everything that we're building works well with Cloud Foundry. And we'd really like to build a community around this. I think there are a lot of other enterprises similar to ours that are Java shops that would like to extend Cloud Foundry and make it work. And if you'd like to get involved and help us with what we're doing, here's my contact information. I'm going to be here until tomorrow, so if you want to come and talk to me directly, that would be great. But thank you for your time. Really appreciate this opportunity to share what we're doing with Cloud Foundry.